Hi everyone, good day to you. You're welcome to Physics 108 class. This is Basic Experimental Class 2. The one of it is Physics 107, which was done in first semester. So Physics 108 is on heat and electricity. So all the experiments you will be partaking in for this particular class will be based on heat and electricity. So I'll just take you through the first experiment, which titles Determination of the Relationship between Resistor Arrangement and Current. Determination of the relationship between resistor arrangement and current. So I'll take you through some introductory aspects of it. You must get to know the objective of the experiment, then the apparatus needed for the experiment, the method or the procedure to use or to follow when performing the experiment. Then when you have your data in the course of your experiment, how do you present your results? How do you present your graph? How will your slope look like? Then for every experiment, there is always a precaution. There are precautions rather taken. So these are the content of this class, what I will be taking you through. So straight to the introduction. I'll just briefly explain to you some basic things that you need to understand for this experiment. The first thing is a resistor. A resistor is a device that acts as a two-terminal passive electrical component that is used to limit or regulate the flow of electric currents in electrical circuits. That device that assists you in limiting or regulating the flow of electric current in electric circuits is called a resistor. So the main purpose of the resistor is to do what? To reduce the current flow and to lower the voltage in any particular portion of the circuit. So there's a particular, there's a common law that most of us we are already used to from our secondary school understanding, which is called Ohm's law. From Ohm's law, we already know that our voltage across a resistor is directly proportional to the current flowing through it, and that is where the V equals IR comes from. Where the R there is the resistance. That resistance is a constant of proportionality. When you remove the proportional sign, it is replaced with a constant, and the constant is in this instance is our R, which is the resistance. So we have V equals to IR according to Ohm's law, where the V is the voltage across the resistor and the I is the current that is flowing through, and the capital letter R is the resistance, which is a constant of proportionality. So we must understand all these basic things, have this basic knowledge of what we are trying to look at. And then we have resistor arrangement. In every circuit, there are ways by which resistors are arranged. Arrangement of resistors are in two forms. The first one is a series arrangement, and the second one is a parallel arrangement. You see, in series circuits, the series arrangement of a resistor, all the components are connected in a single path. They are connected in single paths. That is series. And for a series circuit, you see the current flowing, since all the connections are done in a single path, like on a straight line, the current will flow through on the straight line. And since the current is flowing through on that straight line, it means the current, if the first component on that circuit, on that straight line, is A, and the second component is B, the third component is C, current coming in to A will be the same current that goes to B, the same current that goes to C, because they are all on a straight line. And that is the kind of arrangement we call series arrangement. So in this type of arrangement, if there is any fault in the circuit, maybe in circuit A now, there is a fault, the current entering through A will not be able to get through B because that component A is already faulty. So the current will not be able to move to B, which means B and C will not work. Those components B and C will not work because the current is not flowing through. Do you get me now? Assuming it is B that is faulty, current will enter through A, but will not be able to enter through B to get to C, which means component C will not be able to work because B is faulty. If it is C that is faulty, the current will enter through A, will get to B, but will not be able to pass through C because there is an issue with it. So that is one of the major disadvantage of the series arrangement. If there is any fault in any of the components on that straight line, then some of the other components will not be able to work because current might not pass through them. And that is why we said that if any fault happens in the circuit, the current will not flow through the circuit because it has a single path through which the current flows. The current in a series circuit goes through every component in the circuit. Yes, like I've said. Therefore, all of the components in a series connection carry the same current. Yes, I've already explained that too. A series circuit has only one path through which its current can flow. So it is just that straight line. Since the arrangement is a straight line arrangement, it's a single path arrangement, it only goes in on that straight path. So if there is any issue with any of the components on that straight path, then other components will be affected. And that is for the series arrangement. Now this is an example of a circuit which talks a circuit on series arrangement. You know, if you look at it from the left side where we have applied voltage, at the negative side of the applied voltage there is a current going in from that side and it enters to R1, which is the first resistor. The same current that enters through R1 is going straight to R2, and the one from R2 also is going. It is that same current that is going through the circuit. This is a typical example of a series arrangement. Yes, this is another series arrangement. You can see the arrow from the left side where you have your positive and negative. That is the voltage. You can see that current, capital letter I, entering through the negative side to R3 is going on the reverse side. Now entering through R3 is going to R2, back to R1, and it goes back to the voltage side. It is the same current that will flow. That is a series arrangement. So you have to understand that for a series arrangement, the same current will flow through. The same current will flow through. Now, the parallel arrangement. For parallel arrangement, it doesn't have a single path, unlike the series arrangement. The parallel arrangement has two or more paths. In fact, as long as it is not a single path, the moment you are having 2, 3, 4, then you already have parallel arrangement. So for parallel arrangement, the current passing through are not the same. The moment the current encounters another path, then the current will change, because the current that will enter through path A will be different from the one that will enter through path B. So which means the current will already be divided. So the current that is coming from the source will not go through all the other paths, which means as long as you are having more than a path, your current flowing through will not be the same. And that is why I said that a parallel circuit has 2 or more paths for current to flow through. Now, for this particular arrangement, your voltage that is the same voltage is across all the components, and that's why it is a parallel circuit. So one thing I need you to understand is that for series arrangement we have just a single path. The parallel arrangement you have 2 or more paths. For series arrangement you have the same current flowing through. While for parallel arrangements, what is common to all of them, what they have in common in parallel arrangement is the voltage, unlike the series arrangement. So let's go through this our circuit diagram. Look at the circuit diagram very well. I intentionally picked the one numbered so that it will be easy for you to understand, to get it right. Let's start from this one, from this point one. From point one, you have the I total, which is a current. So look at the I total entering through that 2. By the time you get to 2, there's a particular current that will enter through this line going to 7, and there's another current that will enter through this line going to 3. So the I total coming in from 1, by the time it gets to 2, it will already be divided. It will be divided between this part going to 3 and the part going to 7. So which means you will not have the same amount of current flowing through them anymore, because this one going into 2 coming down as this R1 will be different from the one going into 3 and coming down to 6 as R2. And also it will be different by the time this one that is coming from 2, the one coming from 2 here like this, going to 3, by the time it gets to this junction as well and try to enter 4 and also enter this one going to 6, you have a different current entering to 6 and a different one entering to 4. So that one at that point also will be divided, and that is why you're having your R1 to be 10 kilo ohms, you're having R2 to be 2 kilo ohms, and you're having your R3 to be 1 kilo, which means the total current coming from 1 has changed. So from there you can see that the current that will flow through the circuit will not be the same. They will not have the same current flowing through all of them because of the different branches we already have. And that is that about the parallel arrangement. Now, for this parallel arrangement, okay, look at this now. This one says, in contrast to a series circuit, current still flow to the remaining device in the parallel circuit if any one branch or component is faulty. Now I said that for series arrangement, that if one of those components is faulty, it will affect the other component in the circuit, because as long as one of those components is faulty, the current flowing through the current that gets to that faulty component will not be able to move to the next component, which means it will render all the components it will render the whole circuit useless. Unlike this parallel arrangement, even if one of the components in the circuit is faulty, it will not affect the other component because the current that is flowing through them is not even the same thing. There are different branches that current will enter through the other branch. If it is R1 that is faulty, there are different currents entering through R1, R2. There's another different current entering through R3. So which means R2 and R3 will still continue to function even if R1 is not functioning anymore. The same thing happens for R2. Even if something happens to R2, as long as there is a particular current that has entered through R1, another one that has entered through R3, it won't affect that fault. Then the faulty component, which is R2, will not even affect the whole circuit. It will only affect that one that is faulty. So that is the to me now, I can actually say the parallel arrangement is the best for buildings, for homes, because if you follow the series arrangement in any building or in homes or in our offices, in our places of work, if one of those components is faulty, then the whole building will go blank. There will not be supply. But as long as the parallel arrangement is being followed, even if one part of the component is faulty, it won't affect the other area, because they will work irrespective of the one that is faulty. So there are some relationships between this voltage, the current, and resistance in all parallel circuits. Now take note of this. It says the total voltage of a parallel circuit has the same value as the voltage across each branch. For a parallel circuit, they have the same voltage. The total voltage is the same for a parallel circuit. As a parallel circuit has more than one path for current flow, the number of current paths is determined by the number of load resistors connected in parallel. Yes, the number of the current path is determined by the number of loaders. The number of resistors will determine the number of current path. Yes, because as long as you are having two or more paths, you are already having a parallel resistor. So it is those parts, those branches that will determine the current that will enter, because they have to be dividing the total current. If 15 current is coming through, by the time it gets to the first particular branch, it will divide and goes to the one in front, divide and go backward. It has to keep dividing the total current that is entering, that is coming from the original source. Now look at this. It says the total current in a parallel circuit is the sum of all the individual branch current. Yes, and at the end of the day, the total current in each of those branches, R1, R2, R3, the total current is now the addition of all the current. By the time the addition of all the current that has entered through those resistors, addition of all the current entering through those resistors is the total current coming from the source. Now, so back to the experiment. It says the objective of the experiment is to investigate how the current in the circuit depends on the arrangement of resistor within the circuit. We want to investigate how that current in a particular circuit depends on the arrangement. We already said it, that for series, our current, the same current will flow through. For parallel, we have to divide those currents among the branches depending on the number of branches we have for parallel resistor. So the main aim of the experiment is to investigate how the current in a particular circuit depends on the arrangement of resistors within the circuit. Now the apparatus needed, will be needing 4 known resistors. There is an ammeter, a battery, a switch, and an unknown resistor. Now I used to say this, and I'll continue to say it to us. Please, whenever you are being provided with an apparatus, make sure to check very well if your apparatus are in good form, if they are in good state. There are some apparatus that might be faulty, and it might not be even known to the person providing it to you. But the moment you are trying to use it and you realize that it's not giving you what you expect, or is not working correctly, then you have to signify and let us know immediately. So these are the apparatus we'll be needing for the experiment. Now the procedures to follow. Before I continue, for every experiment you'll be provided, especially for electricity, you'll be provided with, in your manual, we use our practical manuals. So in your practical manual, just like physics 107, you also have practical manual for physics 108, and it's the same lab, the same amount. Now for our practical manual, in the practical manual, under the section of every particular electricity experiment, you see circuit diagrams. So those circuit diagrams are the ones that you will use, that will direct you on ways, on the manner you are going to use in connecting your home. So now the first procedure says you connect an unknown resistor X in series with 4 known resistors. The unknown resistors, which means you don't know the amount of resistor it is, if it is 5 kilo ohms or thereabout, and the known ones you'll be told if it is 1 kilo ohms you have or whatever. So 4 of those, you'll be having an ammeter which you connect. Remember, this one says connect an unknown resistor in series, which means you are connecting all these on a straight path. A battery and a switch. Now these procedures need to be followed accurately. so that you can get the desired result, the expected result. Now the second one says close the switch. Close the switch and record the current in the circuit. Close the switch. The moment you close the switch, your connection will start working. So which means by the time you close the switch on the ammeter, there will be deflection. An ammeter is an instrument used in getting or recording the current flowing in that particular circuit, in that particular connection. So by the time you connect all this, if you want to know the amount of current flowing through, it will be gotten on your ammeter. It will show on your ammeter. The ammeter will take that reading. So by the time you close the switch, the circuit will start working. So and that is why it is said here that you should close the switch and record the current I in the circuit. Now the next one says combine the known resistors in number of different ways. Combine them in different ways. Connect each combination in turn. You know you have combined those 4 known resistors given to you now. Either you are combining them, you are trying to connect them directly in a series or in a parallel. So it says connect each combination in turn in the circuit, keeping resistor X in same place, not changing. Then connect each combination in turn in the circuit, keeping resistor X in the same place. Then you measure and record the current I for each of your combinations. So you have to make sure that all these procedures are being followed. Now this is one of the circuit diagram that will be provided in the practical manual. If you look at this particular circuit diagram very well, what you have there is a series connection. You can see that your R1, R2 and R3 are connected on a straight path. They are all connected on one single path. R1 entering directly into R2, R2 entering directly into R3, which means they have the same current flowing through. When you see the key, that is your switch. The key there, that is your switch. Then you have the battery, that is the voltage. Then you have the high here, that's the current. Now, data processing, result presentation. Now you'll be given the relationship between high and half. It is this particular relationship that you work with that will linearize. Remember we have done how to linearize. Remember where I said y equals to mx plus c, where y is what you'll be plotting on your y-axis for your graph, your m is your slope, your x is what it will be plotted on your x-axis, while your c is the intercept. By the time you linearize 1 over I equals to r over p plus q over p, now this says where p and q are constant. As long as p and q are constant, try to compare y equals to ms plus c with the equation given to you. By the time you compare both, what I mean by compare both is the linearizing I was talking about the other time. You realize that your y equals to 1 over I, your x is r, then you will have 1 over p as your slope, then your intercept will be q over p. Now from here now, if you have a graph, in your graph, from your experiment, you will have gotten your capital letter I, which is the current flowing. You will have gotten your capital letter I. Now from there, you can get your y, which is 1 over I. Since you have I, that is 1 divided by whatever value you are having, your y, that is for your y. Then your x is your r. R, that is the resistance. Now you have your slope. Your slope will be gotten from your graph. You get your slope from your graph. So by the time you get your slope, you can get your P. Assuming for you have already plotted your graph on your slope and you get a slope of, let's say, 2.5. Just say 2.5, which is the slope, equals to 1 over P, so that your P equals to 1 over 2.5. Then you get the value for the P. Now from your graph as well, you get your intercept C. You already know that our intercept is that point where your line of feet, meets either the y or the x axis, that particular point. So if your assuming it's not a straight line graph, it's not a graph that starts from origin. Maybe it has an intercept on either the y or the x axis. Maybe it has intercept at 0.9. So it shows that your intercept is 0.9. Then you have already gotten a value for P from that slope equals to 1 over P. Then you just equate that 0.9 equals to Q over, maybe you got like 5.2 or thereabouts. One, just it's mathematics. That is how you get your value for your Q. Now this is a typical table of what you'll be using it for your presentation, for your data presentation, for your results. Now for every particular resistor arrangement you did, you must get R. There will be an I, which is the current. Then you can get your I over A, which I said is your Y, to be plotted on your Y axis. So this is how your result will be presented on the table. Then the precautions. Number one precaution says that you ensure the connections are made according to the experimental setup. The experimental setup in this instance is where I told you that you should follow instruction and should make sure you check through the circuit diagram being provided and follow the instruction appropriately. So that is what is being talking about here. Then the pointers of the ammeter and voltmeter should be at 0 when no current is flowing. Now by the time you close the switch, I told you it means the current is already flowing. If you are not doing anything with that particular connection anymore, you make sure to open it up. You remove the key to the switch. You remove it. You'll see everything when you come for your physical class, and all this will be reiterated to you. Now you use copper wires as thin as possible for making connections. Then the positive and negative terminals of the voltmeter and the ammeter should be correctly connected. The voltmeter is the one that will read your voltage. The ammeter is the one that will read your current. Avoid loose or frayed wires. Yes, please, if you notice that any of the connecting wires given to you are not too good, you think that they are already old, please make sure to inform us as early as possible before you start your connection, so that it won't affect your output. Now whenever you are reporting your precautions, I noticed this in the previous exam. Some people, they will write ensure note just like they're just writing from the notes, but if you are reporting, use a reported speech, a past tense. You report in such a way that the person reading it will have the mind that you really did this practical yourself. I personalize it. I ensured something you did. I ensured that the connection are made according to, that is how to report a precaution. That is how to give precautions to your teacher when you are being asked for it. Don't just write it in simple terms. Write it in such a way that it will seem as if you are reporting that thing you have done, and all these things are things you will do when you come for your physical class. So thank you very much. With this, we come to the end of this particular experimental session. So by next experiment we'll meet. Thank you. God bless. Bye.